What if we're not alone in the universe, and the first signs of life beyond Earth have already been found? In 2023, scientists using NASA's most powerful space telescope made a discovery so unexpected. It left experts speechless. A planet 120 light-years away, known as K2-18b, just revealed a potential biosignature, a chemical compound that, on Earth, is only produced by living organisms. This isn't a blurry UFO photo or ancient alien speculation. This is hard astrophysical data. And the gas they detected? It's called dimethyl sulfide, or DMS. Here on Earth, DMS is made by tiny ocean creatures, phytoplankton and marine microbes. So why is it showing up in the atmosphere of a planet we've never even visited? Could this be the first real evidence of extraterrestrial life? In this video, we'll break down what scientists actually found, what it means, and why K2-18b may be our strongest candidate yet for alien biology. Buckle up, because this story is not just about space. It's about how close we may be to answering the biggest question of all. Are we alone? In September 2023, a team of international scientists using NASA's James Webb Space Telescope, the most powerful space observatory ever built, announced something extraordinary. They had detected potential traces of dimethyl sulfide, DMS, in the atmosphere of a distant planet known as K2-18b. Now, what makes DMS so special? Here on Earth, DMS is only produced by life, particularly by phytoplankton and other microscopic marine organisms. It's a compound that doesn't just appear out of nowhere. So, if we're detecting it light-years away, it begs the question, could something alive be producing it? K2-18b orbits a red dwarf star about 120 light-years from Earth in the constellation Leo. It's nearly 9 times the size of Earth and sits in the habitable zone, the region where temperatures might allow liquid water to exist. At first, the team detected hints of DMS using JWST's NIRIS and NIRSpec instruments, which scan exoplanet atmospheres as they pass in front of their star. But to be sure, they followed up using the telescope's $10 billion MIRI instrument, capable of detecting light in the mid-infrared range, where many biological compounds leave signatures. The result? MIRI confirmed the possible presence of both DMS and DMDS, dimethyl disulfide, a related molecule that also has biological relevance. This secondary detection, made with a completely different instrument and light spectrum, strengthens the case dramatically. The findings were published in the Astrophysical Journal letters, and the scientific community took notice. It's not confirmation of life, not yet. But it's a massive leap forward. For decades, we've searched for oxygen, water, or methane. But DMS? That's the kind of signal we never expected to see, and certainly not this soon. So what exactly is K2-18b, and why is it attracting so much attention? K2-18b is what astronomers call a Hycean world, a new class of exoplanets first proposed in 2021. The name combines hydrogen and ocean, and that's exactly what they are. Massive planets covered by global oceans, with thick, hydrogen-rich atmospheres. Unlike Earth, which has a rocky surface and a nitrogen-oxygen atmosphere, Hycean worlds could be larger, warmer, and more dynamic. And here's the surprising part. They might actually be more favorable to life than Earth-like planets, at least when it comes to detectability. K2-18b is about 2.6 times wider than Earth and roughly 8.6 times more massive. It orbits its star, a red dwarf, in what's called the habitable zone, meaning it's at just the right distance for liquid water to potentially exist on its surface. According to the recent study, not only is DMS or DMDS present in the atmosphere, but the concentration is shockingly high. We're talking over 10 parts per million, compared to less than 1 part per billion on Earth. That's 10,000 times more. And remember, DMS is a biosignature gas. It's fragile. It breaks down under UV light. So if it's showing up in such high levels on K2-18b, something must be actively producing it. Professor Niku Madhusudan from the University of Cambridge, who led the study, puts it this way. Given everything we know about this planet, a Hycean world with an ocean teeming with life is the scenario that best fits the data. He's not claiming alien life has been discovered, but he's saying the evidence matches the theory. And for the first time, that theory has a name, K2-18b. As exciting as these discoveries sound, scientists are urging caution. Detecting a potential biosignature is one thing. Confirming alien life is something else entirely. While DMS and DMDS are produced biologically on Earth, that doesn't mean they can't be formed through non-biological processes elsewhere. Some geochemical reactions, under the right conditions, could theoretically produce similar molecules, even in the absence of life. Plus, the tools we're using, as powerful as the James Webb Space Telescope is, are still detecting faint traces of light from planets light years away. That data must be carefully analyzed, filtered, and modeled. Even Professor Madhusudan, who led the study, has made it clear. We're not saying we've found alien life. We're saying we found a signal that could be biological and that deserves further investigation. That's why his team is calling for more observations. They want to look at K2-18b again, at different times, under different conditions, and with even more advanced instruments in the future. And the scientific community agrees. Extraordinary claims require extraordinary evidence, and right now, we're only at the first stage. Skeptics also point out that we don't yet fully understand Hycean planets. They're new territory. We don't know how stable their atmospheres are, how their oceans behave, or whether they could support Earth-like chemistry at all. Still, what makes this discovery so compelling is that the DMS signal wasn't detected just once. It appeared twice, using two completely different instruments and non-overlapping wavelengths. That's rare, and it's why scientists aren't dismissing it. They're not jumping to conclusions, but they're not ignoring it either. Something is happening on K2-18b, and whatever it is, it just might change how we search for life in the universe. So, what's next for K2-18b and for the search for alien life? Right now, scientists are planning follow-up observations with the James Webb Space Telescope and other space-based instruments. They'll look for consistency in the atmospheric signals, rule out false positives, and refine their models of Hycean worlds. But even if DMS turns out to be a false alarm, this discovery has already reshaped the search for life. For decades, we focused on Earth-like planets, rocky, with oxygen and water. Now we're expanding that view. Hycean worlds with massive oceans and alien chemistry might be better places to find life than we ever imagined. K2-18b has become a kind of cosmic candidate, a testing ground for what we know and what we still don't. And perhaps that's the most powerful part of this discovery. It reminds us that the search for life isn't just about finding aliens. It's about asking better questions, building better tools, and staying open to what the universe is trying to show us. So, have we found life beyond Earth? Not yet. But with each discovery, each strange signal, and each new question, we're getting closer. And maybe, just maybe, K2-18b is the planet that will finally change everything.